Hi, my name is Victor Cardona, and the purpose of this video is to explore my hypothesis and see whether or not it was backed up by my observational data, those being the surveys. But also to discuss how the litter I found will possibly impact the environment, how long it could remain in the environment, and how it relates to my major, the project that is. Moreover, I hypothesize that the type and quantity of litter will depend on the areas surveyed. So to start off, let's go and check out the places we surveyed, and it's gloomy today. I'm not gonna do anything, I was too tired. Alright, let's day 2, let's go. Alright, I'll get stuff done today, and come on, fresh day, fresh start, we got this. Let's go. Alright, and I don't feel like it, I was way too tired. Oh well. Alright, day 3, we feel refreshed. I forgot to film a scene for this. First up on my list is Shell Beach, and as you can see, it's heavily littered. And what's this? Oh, more trash. That's right, there's trash everywhere. And I seem to have found something. Why am I holding that? That is disgusting. Alright, well, more importantly, over the course of 2 days of conducting a survey here, I found plastic water bottles, beer cans, rusty fish hooks, trash bags, glass bottles, and even a broken fishing pole. Funny enough, this is a popular fishing spot, so it gets a lot of visitors, and judging by the amount of litter and the purpose it originally served, it seems to align with my hypothesis. Okay, so this is the cafeteria. I'm currently walking back and forth aimlessly. I'm gonna keep doing that apparently. Oh cool, okay, I decided to stay still. Awesome. So over the course of 2 days of surveying the specific side of the cafeteria, I actually managed to find a few trash bags, food trays, paper cups, water bottles, and even some plastic silverware. Disgusting. But interestingly enough, this side has a lot of students walk past it, and it just so happens to be more littered than the opposing side. So I guess this data also lines up with my hypothesis. In case you need a refresher, I hypothesize that there will be more litter, more quantities of litter in heavily trafficked areas. So more areas that get more visitors will have more trash related to the services around it. So unfortunately, a lot of the litter I found was made of plastic, a majority of which was found along the beach. This could easily end up in the ocean, where it will remain for hundreds of years, roughly 450 years, but in fact, no one truly knows. However, with exposure to UV rays and the ocean's environment, plastic breaks down into smaller and smaller fragments. This can be devastating for all organisms because those smaller fragments can be swallowed by smaller fish, and then those smaller fish with plastic in their systems will get eaten by bigger fish, and so on and so forth, with the concentration of plastic increasing as it goes up the food chain. And then we catch these fish and eat them, and now we have plastic in our systems, which can increase our chances of getting sick from things such as BPA poisoning. BPA is an industrial chemical that has been used to make certain plastics and resins since the 1950s, and from my knowledge is highly toxic to humans. So basically, the impact of plastic waste making its way into the ocean will be it poisons an entire ecosystem and our own food supply. However, litter with a main component of paper or metal, while I do believe they should be disposed of properly, paper is decomposable. So things like paper food trays, actual paper cups, not the styrofoam ones, and paper napkins, these things that have the possibility of getting blown into the ocean from the cafeteria and impact the ocean's ecosystems, but it will be very minute if anything. On top of that, paper is actually a food source for some organisms, such as termites, which, if given a chance, will eat almost every part of a book, including paper, cloth, and cardboard. It's also worth noting that paper waste takes only about a month or a few weeks, give or take, to break down, and metal waste naturally corrodes away because it gets absorbed by the ground. So things like fish hooks that I found on the first day of surveying the beach, they were rusting, and funny enough, fish hooks are actually meant to dissolve. They can take months, a few years, or up to 50 years. Lastly, I did find styrofoam cups at both locations. Given that we're on an island, it's likely that these would end up in the ocean. It's here that it would cause a lot of the same issues as plastic waste, since it's estimated that the decomposition of styrofoam takes about 500 years. Not only that, but polystyrene foam contains a chemical called styrene, which has been linked to cancer, vision and hearing loss, impaired memory and concentration, and nervous system effects. So in a familiar fashion to how the concentration of plastic in fish increases up the food chain, so will the concentration of styrofoam in the fish's system. Worst case scenario, we eat fish with a high concentration of styrofoam in their system, more specifically polystyrene, and it could cause cancer in us. I won't get into glass because Yeah, it basically becomes sand after a couple thousand years. Next question, where does it go? The environment could aid in breaking down plastic and styrofoam litter through weathering. However, there are some bacteria that could eat the materials and help break it down faster. In other words, biodegrade it. It's a species of bacterium called Adionella sykinensis. I mispronounced that so bad. Paper can be broken down by a number of funguses and bacteriums. It could also be dissolved if it ends up in the ocean or some kind of body of water. And metals that aren't treated or galvanized can be decomposed through natural means and processes such as rusting. Say, for example, it rains, the water could aid in oxidation and move the broken down particles of metal into the ground, where it could get absorbed by plants as nutrients, or it could seep into groundwater, where it could act as minerals for plants, or worst case scenario, it's a toxic metal that seeps into the groundwater and now it's poison. So lastly though, how does this relate to my major? Well, I'm going to be a biomedical engineering major, and something that's pretty important in this field of work is understanding how different materials will interact with human internal systems and or being worn on their bodies for long periods of time. Understanding this is crucial for creating new materials and biomedical technologies. In a similar fashion, this project asks us to understand how different types of litter and their compositions will affect the environment in the long run. To put it simply, I think that this project and my major requires similar understanding of material science. Thank you for listening. This was my final presentation.